This is not just another electric motor, it's a statement. A bold challenge to decades of design that relied on rare earth metals and mechanical limits. Deep inside Germany's engineering labs, Mara has crafted something they call the perfect motor. But it's more than just a name. This machine runs at high power without permanent magnets, avoids wear and tear components, and stays cool under pressure. It borrows from wireless power tech and combines it with a new kind of control. The result? A motor that could shift the future of electric vehicles. No hype, just raw, efficient innovation built from the ground up. A quiet revolution under the hood. The electric vehicle world has been buzzing with bold claims, but one quietly emerging project might just deliver on its promise. In a workshop tucked behind the reputation of German engineering, a company named Mara has built something different, an electric motor that sidesteps the usual rules. It doesn't depend on rare earth magnets, it doesn't overheat during long drives, and it doesn't rely on fragile parts that wear out with time. Instead, Mara's new design embraces a daring concept: power the rotor without wires, brushes, or expensive materials. It sounds like science fiction, but it's very real and very precise. This isn't just about saving money or solving supply chain problems. It's about creating a motor that's lighter, cooler, and more adaptable. While most companies push harder with existing designs, Mara pulled back and asked a deeper question. What if the motor didn't need rare earths at all? That question led to an answer rooted in magnetic fields, wireless energy, and liquid cooling. The result could push electric vehicles farther, longer, and faster than we imagined. But understanding it means breaking down the barriers between tradition and innovation, one component at a time. Breaking free from rare earth dependence. Electric motors have long relied on rare earth metals, materials like neodymium and dysprosium that power permanent magnets. These tiny elements pack a magnetic punch, but they come at a heavy cost. Mining them scars the earth. Processing them is toxic, and sourcing them is tangled in geopolitical knots. For electric vehicles to truly go green, the industry must break this chain. That's where Mara's design steps in. Instead of building around rare earths, their motor cuts them out completely. No magnets, no compromise. The key lies in switching from fixed magnets to electromagnets. Rather than placing permanent magnets inside the spinning rotor, Mara energizes coils using electricity, turning them into magnets only when needed. This gives engineers more control over how the motor behaves at different speeds and loads. It also makes the motor easier to cool and recycle. But creating a spinning electromagnet presents one big problem. How do you get electricity into a moving part without using brushes or slip rings? The answer lies in a familiar technology most people never associate with cars: wireless power transfer. It's the pivot that turns this motor from a theory into a working reality. Power without touch. Getting electricity into a spinning rotor is usually a mechanical mess. Traditional motors use slip rings, circular contacts that spin with the rotor, while brushes press against them to deliver current. But slip rings wear down. The brushes need replacement. Sparks fly. Maintenance grows. That's why Mara's engineers chose to remove them entirely. Instead, they turned to something more elegant: wireless power. Think about how a phone charges when placed on a pad. No wires, just two coils, one in the charger and one in the phone, using a changing magnetic field to pass energy invisibly. Now scale that idea up. That's what Mara did. They built a compact wireless system into the motor's casing, allowing it to send energy directly into the spinning rotor. No physical contact, no moving electrical joints. This system doesn't just improve durability, it also unlocks precision. The strength of the electromagnets in the rotor can now be adjusted in real time. The motor doesn't just spin, it responds. It adapts. It fine-tunes performance based on load, speed, and temperature. That flexibility is something permanent magnets simply can't offer. And with it, the Mara motor steps into a category all its own. The heart of the motor, synchronous precision. At the core of Mara's motor is a concept called an externally excited synchronous motor. In simple terms, the rotor's electromagnets spin perfectly in time with the rotating magnetic field created by the stationary parts, known as the stator. This synchronous dance means the motor delivers smooth, powerful torque with minimal energy loss. Unlike induction motors, which generate magnetic fields by inducing currents in the rotor and tend to be less efficient, this design gives precise control over the rotor's magnet strength. Since the electromagnets are powered externally through wireless energy transfer, the motor can adjust its magnetic force dynamically. This flexibility means the motor operates efficiently across a wide range of speeds and conditions, not just at a fixed point. This technology combines the best of two worlds, the high efficiency and power density of permanent magnet motors and the adaptability of electromagnet-based systems. It's a balance of raw power and delicate control, packaged in a robust, reliable design. For vehicles demanding endurance and performance, especially heavy trucks climbing mountain passes, this motor promises to keep delivering without overheating or losing strength. Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you. Cooling that keeps the motor running strong. High power means heat, and heat is the enemy of electric motors. Overheated windings lose efficiency and can cause permanent damage. Mara tackled this with a cutting-edge cooling system that uses oil flowing directly through the rotor and stator. Unlike air cooling or indirect methods, this system sends specially designed dielectric oil right where it's needed most, around the copper coils that generate the magnetic fields. As the motor spins, oil enters the rotor and is flung outward by centrifugal force, passing through the stator windings and absorbing heat. This hot oil then drains away, carrying warmth out of the motor. Instead of wasting this heat, the system recycles it, using it to warm other parts of the vehicle, like the cabin. This not only improves overall energy efficiency, but also keeps the motor running at peak power for long periods without overheating. This direct oil cooling method is rare in the industry, showcasing Mara's commitment to pushing boundaries. It's not just about raw power, it's about sustaining that power reliably. For trucks or electric cars tackling tough terrain or long hauls, this cooling system could be the difference between average and extraordinary performance. Efficiency that pushes boundaries. Efficiency is the ultimate measure of an electric motor's worth. Mara claims their motor achieves over 95% efficiency, rivaling the best permanent magnet designs and far exceeding traditional induction motors, which usually reach around 85%. This leap isn't accidental. By combining wireless power transfer with precise control over the rotor's electromagnets, Mara minimizes energy lost as heat and friction. Unlike induction motors, where power transfer to the rotor can be inefficient and uncontrollable, this motor delivers electricity directly and with precision. This means vehicles can travel farther on the same battery charge and enjoy instant torque without sacrificing reliability. Though exact power density numbers remain confidential, Mara's motor likely matches or approaches that of permanent magnet motors and potentially doubles that of standard induction types. For heavy-duty vehicles like long-haul trucks, this efficiency means consistent power delivery on steep climbs and long drives without overheating or performance drops. Mara's motor isn't just an improvement, it's a game-changer for sustainable transportation, overcoming the limits of conventional motors. Electric motors typically balance trade-offs. Permanent magnet motors rely on rare earths. Induction motors are less efficient and heavier. Synchronous motors use wear-prone slip rings. Mara's motor eliminates slip rings by employing wireless power transfer, improving durability and reducing maintenance. The rotor's electromagnets receive power contact-free, enabling lighter, more reliable designs. Engineers can actively control magnetic strength to optimize performance under diverse driving conditions, from acceleration to climbing hills. This combination of durability, adaptability, and eco-conscious design suits the demanding needs of next-generation electric vehicles that must perform reliably in real-world conditions. The future impact on the automotive industry. Mara's motor could transform the electric vehicle industry by cutting rare earth dependence, lowering costs, and improving sustainability. Its high power density and advanced cooling fit heavy vehicles needing long-term, tough performance. The motor's ability to adjust magnetic strength on demand enables more efficient and responsive driving across different terrains and loads. Its modular design and durability promise easier maintenance and longer service life, reducing ownership costs. Recycling wasted heat into vehicle heating boosts overall efficiency. Mara's innovation marks a new era of smarter, cleaner, and more resilient electric motors, helping drive the global shift toward greener transportation. This new motor from Mara shows how innovation can reshape an entire industry. By combining wireless power transfer, advanced cooling, and a rare earth-free design, it pushes the limits of what electric motors can achieve. For the automotive world, this means cleaner, more efficient vehicles that perform reliably under the toughest conditions. It's a glimpse into a future where electric power is smarter, more adaptable, and sustainable. While the road ahead is long, breakthroughs like Mara's motor bring us closer to a world powered by innovation, not compromise.